This video will illustrate the model for determining optimal inventory decisions in a two-level supply chain of a wholesaler and retailer. The model will be demonstrated in two modes of operation, decentralized and centralized, and then the differences between these two modes will be examined, and a method for coordinating the supply chain will be developed. We begin with this decentralized mode. The cost assumptions for the retailer and wholesaler are displayed, and those include the fixed ordering cost, the annual unit holding cost, and the average daily demand. The average daily demand in this problem is 60. The working days per year is assumed to be 250. So the average annual demand is 60 times 250, which equals 15,000. The decision variables in this problem are the retailer order quantity, Q, and the wholesaler order multiple, N. The order multiple is the number of times the retailer order quantity is multiplied when determining the wholesaler's order to the distributor in the supply chain. The retailer's holding costs are the average inventory level throughout the year times the annual unit holding cost. The average inventory level during the year is simply the order quantity times 0.5. or the order quantity divided by 2. This is because the largest the retailer's inventory will be is equal to the order quantity, and the smallest it will be is 0, so halfway in the middle of those two values is the average inventory. This is very similar to the assumption in the economic order quantity model. If we multiply the average inventory times the annual unit holding cost, we get the holding cost for the year. So to recap, the retailer's holding costs are the average inventory during the year times the annual unit holding cost. The retailer's ordering costs in the model are the number of orders per year times the fixed ordering cost. The number of orders per year is the annual demand divided by the order quantity. This is then multiplied by the fixed ordering cost. The total cost for the retailer consists of the holding cost and ordering cost, so these two numbers are summed together to get the retailer's total cost. Now we consider the case of the wholesaler. The wholesaler's order quantity is equal to the retailer's order quantity times the wholesaler order multiple. So the retailer's order size is equal to Q, but the wholesaler's order size is equal to 3 times Q, or more specifically, N times Q. The value 3 is in that cell as a starting value right now, but may change once we determine the values that will minimize costs in the model. What this means for holding costs for the wholesaler is that the first Q units that the wholesaler receives from its upstream supplier are passed directly on to the retailer, and it will never hold those units. The wholesaler holding costs then look very much like the retailer, except that we multiply the average inventory times n-1 because the first Q units are passed directly onto the retailer and never held at the wholesaler level. So let's put this into an Excel formula. We know that the average inventory is Q times 1/2, or Q divided by 2, or Q times 0.5. But then we'll put in the wholesaler order multiple minus 1. The 1 represents the first batch that is passed directly onto the retailer. And then we multiply this times the wholesaler annual unit holding cost. The ordering cost for the wholesaler remains the number of orders per year times the fixed ordering cost. But we can see that the number of orders per year for the wholesaler will be different. The wholesaler's order size is N times Q. So we'll build that into the formula. The number of orders per year is the annual demand divided by N times Q. N times Q was also used to calculate the order size here in column C, so that cell could have been used as a reference as well. And this is multiplied times the fixed ordering cost for the wholesaler. The total cost for the wholesaler are the holding cost plus the ordering cost. The supply chain costs, in this case we're modeling two levels of the supply chain, are the total cost for the retailer plus the total cost for the wholesaler. Now we need to discuss the solution to the model. The decentralized solution happens in two phases. First, the retailer will minimize its own costs by choosing the best value for the order quantity. We can do this with Solver. So in Solver, we'll set the total cost for the retailer as the objective and minimize this value. And the only cell that the retailer can change in the decentralized mode is the order quantity. We'll only use one constraint, and that is that the order quantity is greater than or equal to 1. The GRG nonlinear solving method is used in this case to solve the model. Here's an observation about the retailer's costs at its best order quantity. We see that the holding costs are equal to the ordering cost. So in the decentralized mode, the retailer will use the economic order quantity, which is the order quantity where holding costs are equal to ordering cost. Once the retailer selects its order quantity, the wholesaler will then react by choosing its best order multiple. To do this, we'll make a list of some possible values of the order multiple and the wholesaler cost that are associated with them. We need to make sure in the worksheet that the retailer order quantity is the best order quantity that it can choose. And then we'll start the wholesaler order multiple at 1. Once we insert 1 for the wholesaler order multiple, we note that the total costs for the wholesaler are $86.60. And then we examine a multiple of 2. We can see that when we increase the multiple to 2, the total cost for the wholesaler decreased. So 2 is a better solution than 1 for the wholesaler order multiple. Now we need to try a multiple of 3. At a multiple of 3, the wholesaler cost is $54.85, which is again better than the multiple of 2. So we need to keep going until we find the lowest cost associated with a multiple. When we try 4, the wholesaler cost actually increases to $6,062. And this tells us that we've established the wholesaler's best order multiple as 3 for this particular problem. We want to insert 3 back into the model then, so that the model displays the best decentralized solution, which gives us a supply chain cost of $10,681.